Hello students. With example number 2, we'll revisit what we covered with example number 1, which you can find here. And we're going to look at exactly the same problem. That is, you're being informed that on February 29, 2013, the stream concentration of E. coli in the Ottawa River is 10 micrograms per cubic meter. You can consider this as the BOD of the Ottawa River. That is the biological oxygen demand for the Ottawa River, the existing concentration. You're then informed that as a result of heavy precipitation, there is a stream of untreated waste with a concentration of 30 milligrams per liter of E. coli that's being thrown into the Ottawa River untreated. The flow for the Ottawa River, that is the flow of the stream, is 1.95 megaliters per second, and the flow of this untreated waste, the flow of the waste, is 450,000 cubic meters per day. You're being asked, by using the formula that's been given to you, to calculate what the diluted concentration is given this information. So we'll first proceed with solving that. If you notice, this is exactly the same as example number 1. The only difference being that the units are different for the concentration of the stream and the flow of the waste. Okay? So you'll notice that the concentration units don't match and the flow units don't match. So we have a choice. Do we convert these concentration units to that or this to that? Do we convert these flow units to this or this flow unit to that? I'm going to try to stay consistent and convert whatever units we have in this example here, number 2, to the same units we have with example number 1. So I'm going to start first with the concentration of the stream. Currently it shows as 10 micrograms per cubic meter. But what we want this in is in micrograms per liter. Okay, so this is the end result. We want it in micrograms per liter. So what we have to do is convert this cubic meter into liters. So I remind myself by either going through my old notes, reviewing the appropriate textbook, asking my most preferred wireless technology or a friend, how do I convert cubic meters to liter? Well, it turns out that 1 cubic meter is equal to 1,000 liters. So I'm going to employ this conversion to transform these units into my preferred units. And voila. I get that if I convert cubic meters to liters, the concentration in the stream of E. coli is 0.01 megagrams per liter. So what I'm going to do to stay consistent is I'm now going to replace this quantity with a quantity in the units that I prefer. That way I can stay consistent. It is now time to convert this flow of waste from these units to these units. Because if you remember from example number 1, we stuck with these units. Now please note, we could do the opposite. Convert these units to that. It doesn't matter as long as we're consistent. To keep things neat, I'm also going to erase this conversion at the top. Okay, so this is what I have in terms of units. This is what I want. I have to do a fair bit of work to go from this to that. So, first of all, I'm going to remind myself that there is a combination that goes from cubic meters to megaliters. Okay, and it goes as follows. Okay, 1 cubic meter is equal to 1,000 liters. So I went to a known unit of literage. And then I remind myself that to get from liters to megaliters, it's 1,000,000 liters equals 1 megaliter. That only takes care of this. How about taking care of this? We want to go from days to seconds. You think you'd know how to do that? Let's try. 1 day is equal to 24 hours. 1 hour is equal to 3,600 seconds. So I can go from days to seconds. Now if I take all of this and plug it into here appropriately, I can convert this from cubic meters per day to megaliters per second. What I'll do is I'm going to write it out and then write down the final answer. But I am going to erase this because I need the space. Voila. I wrote it down very quickly, but I don't expect you to be able to do it this quickly. I have a lot more experience in doing this. You may not, but the beauty of having this on video is you can take as long as you need. Additionally too, because all your tests and quizzes are online, there is no time limit on how long this takes other than the due date and time. So there's no pressure imposed on you from being able to do this as quickly as possible. Voila. When I crunch this out 2 out of 3 times, I get this number. So I'm now going to replace this number over here so that I keep everything correct on my data side of the board. And voila. Do you see how now this, by bringing it back to more common units or units that you're more familiar with, has now become example number 1. All we have to do now is take each one of these individual quantities, substitute them in your formula, right? Each one of these matches each one of these to get your diluted concentration. Let's do it. Okay, and the answer is, and now that I've calculated the answer, I'm going to provide a concluding statement so that it's easy to find. The final answer is there, unmistakable. Voila. So I skipped all the steps of going from here to there, but you can find them by reviewing example number 1.